Good morning, children. We'll continue with the class now. Already I told you about energy. So what is energy? Energy is nothing but capacity to do work. And how work is measured also you understood now? Work is equal to force into distance covered. So force is, that unit is shown as W. Sorry, work is W. Force is F. And distance covered will be S. Okay. And how is it measured? How is the force measured? Force is measured in Newton and distance traveled is measured in meter. So one that is totally force means it is work done is counted in or calculated in joules, isn't it? So 1 joule is equal to what? Tell me. It is Newton and meter together, isn't it? So it is like 1 Newton meter. So now let us continue with the class now. Already here there is a question here you see. Excuse me. A man moves a cupboard through a distance of 20 meter by applying a force of 500 newtons. N is Newton. Okay. See, a man moves a cupboard through a distance of 20 meter. So meter, I told you, yes, is nothing but distance traveled. So that distance is measured in form of meter and then force is measured in the form of Newton, N. So he has applied force and what he has done, he has moved a cupboard of 20 meter by applying a force of 500 newtons. Calculate the work done by the man. So you have to calculate the work done by the man. Already you know the formula. What is the formula? W is equal to F into S. What is W? Work done. F is force and S is distance covered. Okay. So you can see here solution. F is force. What is the force given there? 500 newtons. Isn't it? Force is 500 newtons. And what is S? S is the distance covered. What is distance covered? It is 20 meter. So 20 meter. What's the formula for work done? Work done. W is equal to F is force into S. S is distance covered. So W is equal to F into S. What is W? Is equal to force is how much? 500. Isn't it? And what is S? Distance covered is 20 meters. So W is equal to 500 into 20. Force is 500, distance is 20 meter. So what is this totally when you calculate? It is coming to 10,000 joules. I said now, work done is calculated in the form of joules. Newton meter is in the form of joules it is. Okay, let me see here. Here, now you can see work done is equal to W is equal to F into S. Work is equal to 500 force and distance is 20. So it comes to, when you multiply this, it comes to 10,000. So work is calculated in the form of joules I said. So it is 10,000 joules. So 10,000 joules, if you are converting, because 10,000 is big number, isn't it? So you are converting that into kilojoules. So when it is kilojoules, what happens? 1 kilo is equal to 1000, right? So now what has happened? You can see here 10,000. I'll write it here. 10,000. Okay. So what is here? 10,000 joules, isn't it? You are converting that joules into kilojoules. Divided by 1000 joules. For kilogram, you are making 1000. So you are dividing this 10,000 by 1000. What will be the answer? These 3 zeros cancel. These 3 zeros cancel. So what is the meaning? 10. So you are converting joules into kilojoules. Conversion of joules into kilojoules. So when you are converting joules into kilojoules, you are dividing it by 1000. Kilo means 1000. So 10,000 you are dividing it by 1000. What is the answer you get? You get 10, isn't it? So 10 kilojoules. See, 10,000 joules is converted into 10 kilojoules. How did you get the 10 kilojoules? By dividing that with 1000. Why 1000? Because kilo means it is 1000 gram. Understood? So you are dividing it by 1000, you will get the answer 10. So 10 will be your kilojoules. Yes, children. Now let us see forms of energy. Energy exists in different forms. One form of energy changes into another form when work is done. Moving objects possess kinetic energy. The energy stored in unmoving objects is called potential energy. A raised hammer stores potential energy, but when it moves and hits a brick, it has kinetic energy. This is how energy changes from one form to another. We will learn more about the different forms of energy in the following pages. Now, what does it mean here? See, energy is there, it is in different forms. So, when it is stationary, means when it is not moving, when it is stationary, it will be potential energy because it is stored energy. Energy is stored in the object, then you call it as potential energy, wherein there is no movement. Then, if it is moving, if any object is moving, means what? It is using the energy and moving, So that energy which is moving, which is helping in moving, we call it as kinetic energy. Now example, just think there is a hammer, okay, and a nail. So what you can do is, okay, just look at this. Just imagine, it's actually a screw, but you imagine this to be a nail and this to be a hammer, okay. So what is happening? Now this hammer is having a stored energy. There is energy in this stored. So what you call that? That is called as potential energy. Now I want to just hit the nail into the wall. Got it? So what am I going to do? I am using this hammer and I am going to hit it. When I go on hitting, what is happening? This nail will start moving. And this hammer is also moving, right? So this energy which is stored is converted into movement. That movement is nothing but that energy which is helping to move is kinetic energy. So you should understand, energy which is stored is potential energy and energy which is helping in moving or movement is called as kinetic energy. Only this you should know. Stored energy is potential energy. Energy which moves is kinetic energy. Okay. So once again I will just read for you. Listen. Energy exists in different forms. One form of energy changes into another form when work is done. That means potential energy is converted to kinetic energy. Again, kinetic energy is converted to potential energy. Understood? So there is a change of energy. Moving objects possess kinetic energy. The energy stored in unmoving objects is called potential energy. A raised hammer stores potential energy, but when it moves and hits a brick, it has kinetic energy. Brick. When you hit, what happens? It will break, isn't it? So then it is kinetic energy. This is how energy changes from one form to another. We will learn more about the different forms of energy in the following pages. What's the first one here? Mechanical energy. Mechanical energy is the energy possessed by an object by virtue of its motion. So how is this mechanical energy formed? It is again by movement. By movement, mechanical energy will take place. So now this is a stick. Okay, what is it now? It is having potential energy. Now what am I going to do? I am moving. What is this now? This is mechanical energy, wherein it helps in movement. Okay. So mechanical energy is the energy possessed by an object by virtue of its motion. So with the motion, what is happening? It is becoming mechanical energy. Position or configuration. So not only motion, position. Now it was like this. It has become like this. Now what has happened to the position? It has changed, no? Okay. And configuration, how it is made. With what it is made. Understood? That is configuration. There are two kinds of mechanical energy, kinetic energy and potential energy. So mechanical energy is of two types. One is kinetic energy, excuse me, and the other one is the potential energy. Now let us go for kinetic energy. The energy possessed by an object by virtue of its motion is known as kinetic energy. See what is happening to the children here? They are running. What is this child doing? The child is cycling. Okay? So what happens here? They are into motion. So what is that which helps in motion? It is kinetic energy. See, the energy possessed by an object by virtue of its motion, movement is called kinetic energy. A moving object has the capacity to do work, isn't it? If there is movement means there is some work going on there. Movement means there is work. So has the capacity to do work. A moving object has the capacity to do work. For example, wind and running water. Wind is blowing, you are not able to see but you can make it now, you can feel it. Wind blowing, you can feel because you can see the leaves and other things will be flying, swaying, isn't it? Moving. Even when the leaves of the trees starts moving means what happens? There is wind blowing, isn't it? And even when you are walking, just what happens? There is a heavy wind, what happens? The mud will start rising, it will come to your eyes. Have you observed that? Yes. Why? Because of the force of the wind. Got it? So for example, wind and running water. Running water also you know, when you go near the riverside or waterfalls, you can see water will be flowing. That is running water. Can rotate turbines to produce electricity. A speeding stone in air can break the glass of a window. And a moving cricket ball can hit the stumps and knock them off. See here, they are given three examples. What is the first one? Wind and running water can rotate turbines to produce electricity. You see, producing electricity in the hydroelectric power station. Say, for example, Shivanasamudra, if you visit, you can see how the hydroelectric power station is working there. Okay? So when the water falls, with a great height water falls, so there will be a great force. There will be a force. So there will be turbines like, see, it will be like this. Okay. So imagine that water falling from a greater height. Water is falling from greater height. So imagine water will be falling. So this is water falls. From here water is falling. Where is it falling? It is falling on this turbine. What happens to this turbine? There will be magnets here. Or what you call it as the electric poles will be there. That north pole, south poles will be there. So what happens here? When the water falls, this will be rotating fast. When it rotates, what happens? There is a production of electricity here. Okay, and then that will be stored in the hydroelectric power station. From there, the electricity will be supplied to the houses, factories, and all those things. So what happens here? The wind and water can rotate turbines. So these are the turbines to produce electricity. Electricity, you understood? No, this one you understood? No. And second example is a speeding stone in air can break the glass of a window. What happens? You have just hit a stone, especially during strikes and all, you can see what people do. They take the stones and they just throw, isn't it? When they throw, what happens? It may go and hit the glass of the window, and what happens to the glass? It will break, right? So there also what is happening? Kinetic energy is there, movement. Okay? And next one is, you can see a moving cricket ball can hit the stumps and knock them off. So you have seen, all of you are familiar with the cricket, isn't it? So what happens? You can see the wickets. No, wicket keeper will be there and umpire will be there, everybody will be there. You see the bowler, what he does? He just throws the ball. When he throws the ball, what happens? It goes and hits what? The stumps or wickets. And what happens? It will fall. The stumps, 3 stumps will be there. You have seen them. It will fall. So what is this? This is also kinetic energy because it is in motion. Now did you understand, children? So wind and running water can rotate turbines to produce electricity. A speeding stone in air can break the glass of a window. A moving cricket ball can hit the stumps and knock them off. Okay. Now, the amount of kinetic energy possessed by an object depends upon the mass of the object and the speed of its motion. So, it depends upon the mass is nothing but weight. It depends upon the weight as well as the speed. So, you have seen the bowlers in the cricket, how they do. No? Spinners will be there, fast bowlers will be there. No? The way they put the ball, it is different. You would have seen that. Okay. So what happens here is the kinetic energy is possessed by an object depends upon the mass, the weight, mass of the object and the speed of its motion and the speed, how fast it is. It is very fast, work will be done faster. If it's slow, work also will be slow. That's the meaning. Greater the mass of the object, greater is its kinetic energy. Weight is also more. What happens? The mass is more. Kinetic energy also will be more. For example, a heavy cricket ball hitting a person would hurt a person more than a light tennis ball would with the same speed. Now, tennis ball you have seen, cricket ball also you have seen. Cricket ball is heavier, tennis ball is very lighter. But when you are hitting it, what happens? You are using the same speed. But when you use the same speed and hit somebody, what happens? Cricket ball hits, it will hurt. But whereas tennis ball will not hurt that much. Why? Because of the light weight. You understood the meaning now? Light weight means tennis ball. Heavy weight is cricket ball. But what you are using to hit is the same speed. You are using the same speed. But what will happen? Cricket ball will hurt more than the tennis ball. Why? Cricket ball is heavier. So it depends upon the mass of an object and the speed of the object. Now also, greater the speed of the object, greater is the kinetic energy. If speed also increases, kinetic energy also increases. If objects are heavier, kinetic energy also will be more. Also, greater the speed of the object, greater is its kinetic energy. For example, a car moving at a speed of 120 kilometers per hour, kmph means kilometer per hour. So, for example, a car moving at a speed of 120 km per hour would cause more damage when it crashes into a wall than it would if it were moving at a speed of 40 kilometers, 40 to 50 km per hour. See, car, two cars are there, okay, and there is a wall. One car is moving with 120 kilometers speed. The other car is moving with 40 to 50 km speed. They both are moving and they hit the wall. Which one will damage more? The car with 120 km speed will damage more than the car with 40 to 50 km speed. You understood? So it depends upon the weight, it depends upon the speed, both. Understood? So that much. You see here, the amount of kinetic energy possessed by an object depends upon the mass of the object and the speed of its motion. Greater the mass of the object, greater is its kinetic energy. For example, a heavy cricket ball hitting a person would hurt a person more than a light tennis ball would with the same speed. Also, greater the speed of the object, greater is its kinetic energy. For example, a car moving at a speed of 120 km per hour would cause more damage when it crashes into a wall than it would if it were moving at a speed of 40 to 50 km per hour. Children, so I will stop it here. We will continue in the next class. Thank you.